Jim Duvall had a bachelor's in electrical engineering from Union College and a master's in computer engineering from Worcester Polytechnic Institute. And sorry, Americans just don't do that right. He is presently director of enterprise strategy for Telestream. His colleague, Eric Openshaw, holds a bachelor's in engineering from the University of New South Wales. He works for Pebble Beach Systems, historically as a software architect for broadcast automation products, and currently as GM for the Americas. Jim, Eric?
Good morning, everyone. Today we're going to be talking about automating digital asset production using SCTE Messages. To put this presentation and the associated paper in context, there's a couple of converging things that have brought Jim and I together with this concept. The first of which is looking at the automation of the use of SCTE triggering messages, specifically the 104 and 35 standards. The traditional use case for these has been for driving local ad insertion. So a classic use case we're looking at here in this animation is a origination facility uplinking a live stream to some type of local broadcast facility or an affiliate. And to drive the local ad insertion, the classic use of these messages was to send a start trigger to begin the ad insertion, and then another one to end the ad insertion. So that's what kind of got these the adoption of these standards started. What we've seen in recent years is the use of a sort of more granular implementation of these messages to actually drive, this is one of the key things we're going to be looking at today, how digital assets can be used, can be created by using triggers within those streams. So in this particular example here, what we're seeing is actually multiple derivatives being created from that single stream. The second thread is really started here at SMPTE last year, and Jim had done a presentation. We were actually both on the same session last year as well. He'd done a presentation looking at using SCTE Messages as an input source to digital asset production. And that really resonated with me. My background is kind of more on the linear origination side, and I'd been involved in a number of deployments of SCTE messaging, and I pulled Jim aside and said, you know, if we can generate a much more granular markup description of these streams, what sort of things can we do from a digital asset production side? And so we kind of been exchanging thoughts for a few months and actually put together a prototype at NAB this year. And really this presentation is a summary of the results of that and some of the ideas we've come up with, and we're really presenting it to the industry to solicit any feedback and any other ideas on the subject. So really what's driving this is we're seeing in the business from a content production side sometimes in excess of 80 versions of any single program asset that need to be distributed to different digital content consumption endpoints. So that could be VOD, OTT, and so on. And the variations between these different versions of the assets are typically very minor. It could be as simple as how the ad breaks are cut out or replaced and so on. And so sort of zooming out and looking at this as an entire ecosystem, the proposition here is that whole process is really ripe for automation, and we can see potentially order of magnitude increases in efficiency in this sort of solution. So we're going to be leveraging the existing SCTE 104 and 35 technologies. But really what we're proposing here is a way to create a very generic and granular formalized subset of that we can use to describe a stream to a sufficient level of detail that the downstream processing, the creation of these digital assets, that we can actually cover a huge number of the use cases that are out there just using a single markup schema. So zooming in on the origination side, Jim's going to be taking a look at more of the downstream stuff. But really the key to maximizing the reusability of a linear stream is in the granularity of the signaling that we can put in it. And clearly the origination system is where all of that timing information and content information is known. So looking at a sort of somewhat simplistic version of an origination system here, the story starts with a traffic or scheduling system that produces our broadcast schedule. That is loaded into a playout automation system, which is in turn controlling some type of video engine, doing the video playback, doing the graphics, the audio mixing, and so on, and also injecting the Nielsen encoding and the encoding of the SCTE messages. What we're outputting in this particular example out of this playout system is 2 mezzanine level IP streams, first of which is the as broadcast stream, and the second is a clean stream. And Jim's going to look at some of the use cases as to how those particular streams are used to create these different derivatives of the digital assets. One thing I wanted to touch on really quickly, I won't go into a lot of detail, but there's more information in the paper on this, is that having been involved with some of the implementations of origination systems that are trying to optimize and enable the creation of these digital assets, I've seen a number of inefficiencies been built into systems specifically for this reason, knowing that there's a need for creating these digital assets. One of which, there's a couple of key ones here I just want to touch on quickly, one of which is building out dedicated air chains specifically for the creation of a linear stream that is going to be used for digital delivery. And the main reasons that I've seen for doing this are for covering up certain parts of the content, parts of the stream that do not necessarily have rights for digital delivery. And the other one is creating effectively a parallel stream of SCTE messaging for different use cases. And what I discuss in the paper is that most of these use cases have been considered and baked into the SCTE standards. And while there may well be situations where the need for separate air chains is necessary, a lot of the time these use cases can be taken care of with some more thoughtful implementation of the messaging. The second one is the emergence of glue applications, which effectively sit on the side of the automation system, and due to what are effectively deficiencies in the origination system in their ability to inject the granularity of messages that we now need in this ecosystem, these glue applications poll the playout system and derive the messages that need to be injected effectively as a bolt-on service. A lot of the time that is effective, but it comes at a cost, a financial cost, a complexity cost, and certainly in cases where there's a lot of live production going on, these applications don't always have the ability to react to late-breaking changes in the playlist relative to the live events. So really the underpinning concept of this paper and the presentation is what we've called a schema. So it's effectively a constrained subset of the SCTE 104 and 35 messaging standards. And the main reason why we're presenting this is that my experience with the implementations of these sorts of systems, both from an origination network side and also working with MVPDs, every time, pretty much, I'm handed a document that is a specification, a site-specific specification of how they've implemented the specification. And that's a problem, because that really says to me that the vendors are talking different languages and there's going to be interoperability problems. And sure enough, with pretty much every implementation, there are interoperability problems relative to the creation and interpretation of the 104 messages. So really, what we're looking to do here is take a standard that is this wide and has a number of different use cases and say, for the digital asset production use cases, and Jim, with this schema, he's able to cover a huge amount of these different use cases. We're going to constrain it. Maybe we're going to formalize it, and maybe there's going to be 2 or 3 different variants of this, but we're going to create a very granular but generic schema that can be used for driving these digital asset production workflows. Fundamentally, what we're trying to do is to create a stream that is self-describing. What we're looking at here in this particular example is a classic program broadcast. There's 3 segments, there's 2 breaks. We're marking nested segments within this stream using the segmentation descriptors in the SCTE standards for the program, the segments within that, the breaks, what's national, what's local ad space, and content descriptors for the individual elements. And from that, we create what is effectively a passive description of the stream. I use the word passive because for those of you who have some exposure to the SCTE 104 and 35 standards, there's some messaging constructs within that I would consider more directive. So when I say directive, what I mean is something like a splice request or a placement opportunity, which is really a function of a contractual agreement between a provider and a distributor. What we're looking at here is to take that away and look at something that is purely generic and self-describing. And one of the things that I talk about in the paper, just quickly before I hand over to Jim, is to how different SCTE 104 and 35 messaging streams can actually coexist. So the fact that this may not cover every single use case doesn't mean that it can't coexist in the same stream as other messaging constructs for different use cases. So with that, I'm going to hand over to Jim, who's going to take a closer look at what we can do with this schema.
Thank you, Eric. This is good to be here. Darren, I wanted to thank you because I think if we ever do this again, we should change the name of this paper to Smart Endpoints and Dumb Pipes because it's exactly what we're trying to do. So we're going to just borrow that. And Bill, it's not an American thing. It's a out of New England thing. It's Worcester is how you say that, right? So thank you. So continuing on with this one field that's specified in the SCTE, it's actually the SCTE 35 specification and referenced in 104, something called segmentation type ID, is a very rich set of descriptors that are all identified by codes that is your friend if you're trying to make this migration to what we're talking about. The thing about that is that over the course of time, that specification, the last 2 revisions certainly have increased the definition of what you can use. It's in that table. So different use cases are being considered and developed there. And if you have things that aren't covered, then it's certainly a place to do that. And I'd like to echo some of the comments Eric made. This is ripe for standardization. Some of the comments that have made from the previous speakers all talked about the need for standard interfaces in order for these smart endpoints and dumb pipes to work. So this is what we'd like to point to. So once we have that documented stream, so the illustration on the top of that picture represents the stream that's flowing into the network, right? So it's actually coming in off of SDI. And what we want to do at that point, at that edge, is to capture the information that's in that as a file and then turn that into an asset that's prepared for operation in a completely digital environment. So, and the idea with this next is that to take that, if you look at that illustration, the original picture that Eric had there, there's actually program boundaries that are on that. The capture system that's receiving that is recognizing those. That's the first step in the chain to actually trim out those segments and save that as a file. The next set of things that we're going to talk about is how do you convert that into a deliverable asset. That asset that you're looking at is something that's called a stream conditioned VOD file. I don't know if you know what that, if everybody knows that term, but if you've worked with that, the concept is that you will make one long file, but insert iframe edit points where the ad breaks, where you need to come out of an ad break, right? So that involves just inserting a few black frames, forcing the iframes where we need them to be while still maintaining the GOP structure that's required for cable, all right? So it's kind of archaic, but it works well with the systems that they have because the goal for that is to be able to play that same file on a system that can do dynamic ad insertion and one that can't, right? And so what we're looking to do is identify out of that broadcast stream where the replaceable parts are, and then from there, generate the metadata that's going to go not only to the DIA playback system and the ad insertion system, but also provide Nielsen metadata that has to be distributed for that particular asset type, and it has to get distributed to 3 places. That's just one, right? Then they'll show you where there are many, many other variations of that. As Eric said, I won't show you all 80. That would take a while, but there certainly is a number of these. So the architectural configuration in our dumb pipe that we're looking at here actually starts at the ingest point where we have these process nodes, right? So what Eric described of taking that stream, fully describing the elements within that in such a way that any one of those process nodes could evaluate that description and then perform the right operations on that in order to produce the desired output is what we're after, right? And we've, by the way, this is, Eric mentioned the system that we have put together at NAB, but we've also done real deployments of this across time. It's just the, we struggled with them one at a time. It was actually Eric's question to me last year that created this other approach that we're describing here. So in order to produce that output that we talked about, and the previous slide had what the video file would look like. There's also a specific set of metadata that has to be distributed, in this case, to the group that's doing the ad insertion process. So if there's a dynamic ad that's going to be played into a VOD file, which, by the way, is a pretty intriguing concept in and of itself, this is the small bit of metadata that needs to be produced to do it. What's in the red boxes is what defines that breakpoint, right? So if you, and I don't know, I'll leave that up so you'll be able to see it, but you see the numbers in that talk about something that's at 16 minutes and 38 seconds and some number of frames into that file. That's where that iframe was here, which are represented by those big black spots. So the information that comes into the SDI gets captured in that file and then is extracted is here. So there's 2 important things. I mentioned that segmentation type ID, and you'll see there's the ID for this particular event that it's describing is identified as type 48, and we'll see what that means in a second. But also the important thing is this notion of a pre-roll time. For robustness, what people do, I've seen a couple of different concepts for this. One is just to provide sufficient pre-roll so that you actually can process all this, do all this processing, capture it, and then post-process it properly. The other thing is that there have been, in more than one situation, that the SCTE messages don't necessarily make it into the stream as intended, right? They may be dropped, they may be missed. There are various reasons that can cause that. So what you'll see is that they'll actually give you 3 of those messages, each with different timings on them, so that you have a couple of chances to pick it up in case something goes wrong. But once it's captured in the file, you have the information available to you. The next thing is that there's a set of rules that are applied for each of these different process nodes, right? So in this case, I'm showing 3. There's a rules file here that says if I see a segmentation type ID of 48, that means a national break start for the processing that I'm going to do. So if you remember, that means I've got to make sure that I do that insertion of the black frames and align the iframe to where we need it to go. So that first message in there describes that to us, and that then gets transformed into a set of commands. So this is all happening now within that smart endpoint, a set of commands that describe where we want that break to be. Now, one of the things you'll notice here is that the ID that you, or the time stamp that you see in here for the break that occurred is actually different than the one in the final result that's shown at the top. And that's because this is before we've done the processing. This is the command that comes in and says, on the source material, this is where that break needs to go, and the result is that we get the break where we need it to be on the output, and the result gets communicated to everybody downstream. And by the way, the problem with getting on the wrong spot are sloppy ad breaks, flash frames, bad restarts of the content, right? So all considered to be bad form in what we do. So the system would look something like this then in its entirety. So we have that stream to the left that's actually coming with the markup in it. Each of these different process nodes it goes into a capture system, saved as files, and then each of the different process nodes will then pick it up and produce the various forms. So some examples that I am showing here are at the top is actually propagating the live stream off to an origination server where that's going to be turned into a live over-the-top stream with ad breaks in it. So that's one of the implementations that we did. The second one is just saving the files. A third of the various types of VOD, I just showed 3 that are going to different types of cable systems and over-the-top systems. One is the first example that we talked about. That would be considered, it's called the C3 type piece of content. So for the first 3 days, to get the most value for your ads, you have to produce exactly what was done online, except for any local ad spots that were available. Those can be replaced. The one below it is what would be called D4. That is what happens after it's been in the VOD carousel for 3 days and it's still coming from your Comcast VOD carousel. But now all those ad breaks are replaced, and you can put anything in there that you want, so that you don't have that original content. Plus, at least the original ad content, you don't want to have the graphics that went with the off-air broadcast. You don't want to have the audio that necessarily went with that, and you certainly want that to be coming from the clean feed. So all of those, and then the last one is your over-the-top type deliverable, where this is going to someplace like a Bright Cove that's going to be playing this out with a completely different ad insertion system, right? That's going to be coming as an internet provider, somebody like a Freewheel. That is yet another implementation where you put large segments of black in there, and as they transcode it for their own environment, they just need to know where to look within that black to find a place to place the ads. So examples of all the things you need to do all derive from that exact same markup, right? It's just a different processing implementation when we get to the end of it. So this is just a more detailed example of the system that we showed at NAB. So there was the clean feed and the as-aired feed. The as-aired feed is what's providing that markup information that gets applied to both of them. And from that, we made those various elements that we talked about, and also propagated a live stream through that. I'll talk about that for just a minute. That live stream does 2 things. One, it gets converted into something that can be played as an adaptive bitrate file over the internet, and it also preserves the ad breaks that were put into there so that ads could be inserted into it. Now, for the purpose of being perfectly truthful, when we did the ad insertions at NAB, we actually did that in the same server that was doing the transcoding and the production of the file and the packaging of it. We did the ad insertion at that point, so where we would just change the manifest of the adaptive bitrate file in order to play the ad out of that. If you really want to implement that in a real environment, what you would want to do is put a separate origin server with a just-in-time packager on it, but still propagate that same set of metadata that we used into that system, and then that would communicate with the different ad serving networks in order to choose the right manifest changes that you'd want to make so that the ads played in the system. And by the way, if you ever watch any of these other over-the-top services that they're available, on in dozens of places now, you will see in those players where if you're watching them along the bottom of the screen, there'll be a little mark on there, and it'll stop and play the ad, and you can't do anything about that. When it gets to that, you're watching that ad. That's what that system is doing for them, right? So even if it's a VOD playback or if it's a live stream, it's providing that same functionality. So that's yet to be fully vetted, but that'd be the next step in this process, but it is an evolution. So in terms of considerations of this, the important things to know, and Eric emphasized this, but I want to say it again, is you want to have a very formal schema that you're using in your implementation. And from that, and with that point, it's good to know that just about everybody in this room is starting from a good point, because you're either in one of 2 places. I think in all the experiences that we've had right now, you're in one of 2 places. One is you're using still the original SCTE messaging system that's used for the local broadcast ad insertion. You haven't started down this path yet, right? So this is a really good time to recognize that, and as you go through that process, look at some of these concepts of being able to describe that stream. So when you capture it, you can make all these other updates from it. So it's a very good place to start. If you're already in the process of implementing this, take the time to look at these descriptive methods, because trying to go from where you are exactly today and just re-implement that with the new schema means you'll miss a big opportunity on this, but it's very easy to also cash in on it as well, because it's a matter of just taking the time to learn about this and working with all the constituents that are in your delivery chains to make sure that that works. The other thing is that Eric mentioned it in his talk too, but you can see as you start mixing and matching various pieces of equipment, precision errors can happen in the placement of the messages, right? So if you miss by just a frame or two, that's enough that it's visible to somebody watching. So take the time to really test this rigorously. Put the thing in a player, walk through, look at the frames, make sure you know exactly what it is you're getting, and test and push back on anything that's not precise, because you can achieve this completely frame accurately. The other good thing about this is that if the schema, of course, needs to be backward compatible to support the ad insertion systems that you have, but at the same time, you can extend to a really broad set of applications and also a completely more broad and bigger set of deployment environments. So this works capturing on the ground, sending it to the cloud, deploying out of there. There's a lot of things that you can do with this by putting that intelligence into the file itself. So in conclusion, using this real-time system to take care of the timing issues that happen in a traditional broadcast environment, meaning a ball game runs long, there's a show gets interrupted by some other event. All of those things happen in real time, and up until we have the opportunity to tag these things as they're being built, the reliance on just clip it at the wall clock time and save that as the asset, and we'll clean it up later, goes away, right? So this can become a completely automated process for producing these finished assets. This modular architecture is terrific because you can scale this in your building, you can scale it at a colo, you can scale it at Amazon, right? As long as you have the assets in a way that can be interpreted by these smart endpoints, you can deploy this any way you want. And the technology exists to deploy this end to end. Your friends in this, just remember if you're in the process of writing these schemas, that segmentation type ID, take advantage of what's in there. And the pre-roll fields, just make sure that you know how much time you have in that chain in order to get all the information through. And with that, it becomes a really solid foundation. Just those two items give you a really solid foundation for everything else that you wish to do. And then along with that, there's, like I said, there's a rich set of descriptors that are in that today. But in order for this to become easy so that there's not bespoke code at the receiving end of this, is really develop some formality in the process. So if there's a message type that you don't see, a descriptor that you don't have, the best way to implement that would be to change that through the standards process rather than encode it in some sequence of messages that you build into your own schema, because that is what's going to make this difficult to maintain over time. So like the other speakers before us, we make the plea, please work for the standardization of these type of schemas, and if you have any ideas, if this sparks any concepts or thoughts or different types of implementations that you would want to address, we'd both like to hear about it because we'd like to add that to the efforts that we have ongoing in order to make this work. So with that, I'll conclude, and if there's any questions, we'll be happy to take them. Eric, do you want to come up for these two?
Yes, hi, I'm Jim O'Brien from Avico. We've enjoyed all of the nuances in interfacing with several different stream splicing systems. And, in some countries, there's just remarkable stuff going on for head-end level insertion of not just spots, but also news and sports segments derived from master control. And one of the cool things about what's going on in some places is master control automation, if it has the proper sophistication. It can keep track of what's going on out at those places. So in the example you gave, a change needs to happen. It's master control. We deal with rapid changes all the time. And that's out of band signaling. So it's really simple. It's very complex to develop, but it's really simple to operate. And that may be a fertile field for standardizing messaging, because, you know, interfacing with hundreds of different broadcast products, as you guys all know, it takes a lot of work, and, you know, every stream splicing subsystem is a little bit different. It's realistic to expect that for a while, because they're usually derived from specific big projects inside media companies. And be careful about stripping off parts of the schema. You know, I was honored to be on that original committee, and, you know, some companies are using those schemas for very specific things. So, you know, caution is the order of the day, and trying to regress what's in those, and it's short messaging anyway. So it's wonderful work. We'd love to pitch in and take part, because some of the things going on out there are really quite compatible with the ideas, and they're on the air.
Good, thank you.
Yeah, I'll just make one quick comment on that. I think that just to sort of be clear on the proposition here, the intention is not to take anything out of the standard and strip back any of the existing implementations. There's really, I think, the main takeaway that we want the audience to understand is that a lot of the implementations from a digital asset production standpoint, understanding that a lot of the sort of over-the-air and cable distribution of linear streams may have additional use cases associated with them. But from what Jim was able to show from that one schema, is it worth at least giving it a name, quite aside from anything else, so that as a master control vendor, you can say, I comply to schema X, and therefore we know that certain systems that are going to be interpreting that stream at least have something a little firmer to hold on to from a sort of compliance and interoperability standpoint than a full implementation of SCTE 104, which at the moment is this wide. So I expect that you've come across interoperability issues as well, and, you know, really I think the main point is to see what percentage of those use cases can be fulfilled by some type of named constrained schema within that, but still allowing the broader specification to be available for those other use cases.
And just to follow on that, I know we're short of time, Bill, so yeah, so just to follow on that is that in every situation I've been through so far where it's been successful, the people that were implementing the schema didn't fully understand the downstream requirements of what it was people wanted to do with that in this particular environment. And so either didn't understand which pieces they needed to implement or how they should describe those, you know, those files, right? And once we get past that, then it's almost automatic, right? But it's actually getting the development team to reach that agreement with the other people in their organization is what really took a lot of time in all those development efforts.
Just Steve Riddle, just a quick question. Definitely doing exactly what you talked about. The one thing that you probably want to add in your next version would be SCTE 224, which is the out-of-band metadata describing how to create those 80 different variants out of the spec. So to keep the in-band messaging simple, and then use the out-of-band metadata to figure out how to create the variants that you need.
I think that's a good idea, because the way I interpret what I know about the SCTE 224 document is really these sort of contractual obligations that people have with their providers. So that information certainly should merge with what's being done here in order to produce that final output. I would agree with that. Okay. Thank you very much, everybody.